Bismillahirrahmanirrahim. Hello everyone. I hope you are all doing well. I welcome you all in class of real analysis by Robert Bartle. In today's lecture, we will discuss last two questions of exercise 2.2. These questions are related to minimum, maximum, and middle number of the set. So these questions are very interesting questions. So let us discuss. This is question number 18. In this question, we have to show that if A and B are two real numbers, then the maximum value of this set AB, which will be any of the number A or B. It is given by the formula 1 over 2 A plus B plus A minus B absolute. And the minimum value of this set is simply given by the formula 1 by 2 A plus B minus A minus B absolute. Its B part says if A, B, C are three real numbers, then the minimum value of this set is simply given by minimum of A, B and C. So firstly we start from part A. I will prove this part by using two ways. In part A we have to show the maximum value of AB is 1 by 2 A plus B plus A minus B. I will consider here two cases. Case number 1. If the maximum value of the left hand side A and B, the maximum value of this set is A, we can write A as by dividing and multiply with 2. We have 1 by 2 2A. The inner expression 2A can be written as A plus A. By adding and subtracting B, we have A plus B, A minus B. Next, consider case number 2. In case number 2, suppose maximum of AB is equal to B. Again, by multiply and dividing by 2, we have 1 by 2 into 2B. The inner 2B can be written as B plus B. Now adding and subtracting A, we have A plus B minus A. By taking minus as a common from this bracket, we have A plus B minus A minus B. Now combining both of the cases, in the first case, the first bracket in both of the cases is same, while the second bracket in the first case is A minus B and in the second case is minus time A minus B. In the first case, we have assumed that the maximum value of AB is equal to A. When A is greater than or equal to B, the absolute value of A minus B is simply equal to A minus B. In case when your A is less than or equal to B, or you can say B is greater than or equal to A, in this case your absolute value A minus B is equal to minus time A minus B, or this can be written as minus time B minus A. Sorry. So these two values can be combined into a single value, that is their absolute value. That is required to prove. Just for our understanding, you can verify this formula by a simple example. If you take A is equal to 2 and B is equal to 5, then the left hand side, the maximum value of 2 and 5 is simply equal to 5, and the right hand side gives, by substituting A is equal to 2 and B is equal to 5 here, this becomes 2 plus 5 plus absolute value of 2 minus 5. 2 minus 5 is minus 3, but its absolute value will be 3. 7 plus 3, 10. 10 by 2 is equal to 5. So left hand side is equal to right hand side. We can prove this part by an alternative way. Suppose given AB are real number. Suppose A is greater than or equal to B. If A is greater than or equal to B, then clearly its absolute value will be equal to A minus B. Hence, in this part actually I will solve the right hand side. That is 1 by 2 A plus B, A minus B absolute. As A minus B absolute is equal to A minus B, so by cancelling out B, we have 1 by 2 is equal into 2A, and this gives equal to A, which is the maximum value of AB. Because A is greater than or equal to B, then clearly maximum value of A set AB is equal to A. In case when your b is greater than or equal to a, then its absolute value is equal to b minus a, and hence now the formula gives its absolute value is equal to b minus a. By cancelling a, we have 1 by 2 into 2b. By cancelling 2, we have remaining b. As b is greater than or equal to a, that's why now the maximum value of this set is equal to b. Since exactly one of the two cases must occur, the formula hold for all AB belong to R. Similarly, we can show that the minimum value of AB is given by the formula. This is your assignment. Next, we move towards its B part. Its B part consists on 3 elements. The minimum value of set ABC is given by minimum of AB, set ABC. We set D is equal to minimum of the A and B. By definition of minimum, D will be less than or equal to A and also less than or equal to B. So the right hand side can be written as this is equal to D. So this becomes minimum of D and C. Now we consider two cases. Case number 1, if D is less than or equal to C, as by the above part, if D is less than or equal to C, then clearly the minimum value of DC will be equal to D. This shows that D is less than or equal to A, D is less than or equal to B. This is given by these inequality. And in D is less than or equal to C, this is our assumption. So from these three inequalities, this show these three inequalities, we have D is the smaller number among A, B, and C. So D is the smaller of these three numbers A, B, C. So that's why the minimum value of set ABC equal to D, and which is also minimum value of DC, set DC. So for the case number 1, left hand side is equal to right hand side. In case number 2, if D is greater than C, then clearly the minimum number is C here. As D is greater than or equal to A, D is greater than or equal to B, by our assumption here, this is clear from here. And C is less than D by our assumption. This shows that as C is less than D and further D is less than or equal to A and D is less than or equal to B, this shows that C is less than A, C is less than B. So in this case, when D is greater than C, then C is always less than A and B. Next, we consider the left hand side of the question. The minimum value of ABC is actually the smaller of the three elements A, B, and C, which is equal to C here, and which is also equal to the minimum of this set. C is also minimum of this set. By replacing the value of D, which is equal to the set minimum of AB, hence from this case also we have left hand side is equal to right hand side. Hence from both cases we have proved the result. Next we move towards its last question number 19. Actually this question is related to the middle number. Show that if ABC are real number, then the middle number is given by is denoted by mid of ABC, and it is equal to minimum of maximum of AB, maximum of BC, maximum of CA. What is middle number? You know, middle number is the element of the set that is neither maximum nor minimum. For example, if we have elements 1, 2, 3, then clearly you know 2 is the middle number, which is neither maximum nor minimum of the set. So for 3 elements ABC, we can consider 6 possible cases. I am assuming one of the case. There are the 6 possible ordering of ABC. Because the expression is symmetric, it's sufficient to consider one representative case. The other cases you can assume also. This is first case, A less than or equal to B, B less than or equal to C. The second case will be A less than or equal to C, C less than or equal to B. This will be second case. Third case, B is less than or equal to A and A is less than or equal to C. For the fourth case, B is less than or equal to C, C less than or equal to A. Similarly, you can consider the remaining two cases also. But it is sufficient to consider only one case. So we are assuming A less than or equal to B, B less than or equal to C here. In this case, when A is less than or equal to B, B is less than or equal to C, then the middle number of these three numbers is simply equal to the B. Next we compute right hand side. This is the left hand side of our question. Next we compute right hand side of the given expression. What is the right hand side? This is the right hand side of the question. In this side, we have to calculate maximum of these three sets. Okay. Under the assumption A less than or equal to B, B less than or equal to C, the maximum of these two number AB is B, because B is greater than or equal to A here. Maximum of BC is clearly C, and maximum of A and C is C under this assumption. Hence, by substituting the value of this set, maximum of AB which is equal to B, maximum of BC which is equal to C, maximum of AC which is equal to C. Now among these three numbers we have to calculate the value, we have to find the minimum number. The minimum number of this set BC is clearly B under this assumption. So which is equal to the left hand side, because in the left hand side your answer is also B here, and on the right hand side answer is also B here. Hence left hand side is equal to right hand side. So this way we have completed exercise 2.2. Alhamdulillah. Inshallah, in the next lecture we will discuss a very core topic of real analysis, that is the supremum and infimum property of R. Sorry. So if you find this lecture helpful, kindly like, share and subscribe my channel. See you in the next lecture. Take care. Allah Hafiz.